Delta 1398, declaring an emergency. We've got plenty of fuel, and onboard souls are have a fume event, kind of like smoke in the cabin.
Delta 1398, right inside the Boston Airport. The vector is turn left heading of a 130, 130 heading. Descend to maintain probable 240.
Left turn heading 130-240 descent, Delta 1398. We'll be right back.
Welcome to the final episode of our 3-part series on ATA-24 electrical power for the Boeing 737. Over the past 2 videos, we have explored the fundamentals of the B737 electrical system, from the power generation to the distribution, and from AC power to DC power. Now it's time to bring it all together. In this concluding chapter, we will dive into advanced control via 3-panel. So there is a 3-panel to control the electrical system. This 3-panel located on the P5 panel, as we mentioned in the first and second part of this video. Number 1 is electrical meter and battery and galley power module, located in B5-13, and the second one is generator drive and standby power module, located in B5-5, and number 3 is AC system generator and ABU module, located in B5-4. The switches on this panels send signal to the LRU that control positions and portions of the systems. The LRU then energized or de-energized relay or breakers to control electrical power. And again, as we mentioned before, the breakers allow power to the buses. A breaker closes to let power through it. The breakers close when you command the GCU or generator control unit to close it. The GCU closes the breaker only when power is good and no other power sources is on the bus. There are 3 famous control or contactor in the ATA-24, which is external power contactor or EBC, and ABU power breaker or ABB, and generator control breaker or GCB. Starting with electrical meter and battery and galley power panel. The battery switch control relays that supply battery power to the DC buses and the standby bus. The alphanumeric display shows up to 2 lines of maintenance information, and the AC meter selector is a
7-position rotary switch. The AC meter selector selects the AC channel to show the AC volts and AC amps and CBS or cycle per second for frequency sections of the alphanumeric display. Selection of Gen 1 or even ABU Gen or Gen 2 tells the display to show the voltage and current and the frequency related to the 3 mentioned sources. Selection of a standby power, ground power, or inverter makes the display show the voltage and the frequency. You use the test position of the AC meter selector when you do a B5-13 byte. So there are aircraft equipped with the galley switch. The galley switch supplies AC power to galleys when the AC transfer bus have power. And aircraft with a cabin utility and IFE passenger seat switch. The first switch, which is cabin/utility switch, supplies electrical power to galleys and numerous utilities, such as heater, and ovens and freezers.
The IFE passenger seat switch supplies electrical power to the passenger and entertainment system. The second panel, which is generator drive and standby power module. So we use the generator drive disconnect switch to do a manual disconnect of the IDG input shafts from the engine accessory gearbox or AGB. The engine start lever must also be in the idle to do the manual disconnect, and we do the manual disconnect of an IDG when in case of a high temperature or low pressure of the oil for certain. The generator drive light shows an IDG malfunction. The light comes on when the IDG oil pressure is less than operating limits or for an under frequency condition. The standby bar switch gives a manual control to disable the standby buses or to override the automatic control of the standby bus from AC transfer bus 1 to the battery or inverter power. The standby bar off light comes on when any of these buses do not have power: AC standby bus, DC standby bus, and the battery bus. Our last panel is AC system generator and APU module. Each IDG has a generator switch. Each switch supplies electrical on-off signal to let the GCU close the generator control breaker. The APU has two generator switches. Each switch supplies electrical on-off signal to let the APU GCU close to the APU power breaker. The bus transfer switch provides on-off control of the automatic bus transfer function. The bus power control unit or BPCU senses bus transfer switch position. The BPCU controls the bus tie breaker or BTBs. The transfer bus off light give indication of power status on each AC transfer bus. A transfer bus off light comes on when no power is on its transfer bus. Thus, the GCB and the BTB are open when a transfer bus off light is on. The source of light shows that a transfer bus is not energized from the selected power sources. For example, the left source of light comes on when GCB1 trips and the AC transfer bus 1 receives power through the bus tie breaker from the IDG2. The generator off bus light provide indication of a generator control breaker or GCB position. Generator off bus light is off when its GCB is closed. This shows that the AC transfer bus has power from the IDG. The APU gen off bus annunciator is on when the APU is on and the ABB is open. This shows the APU is ready to load or RTL, and the generator is not on either transfer bus. The ground bar switch supplies manual control of the external bar contactor. The BPCU receive on-off signal from the ground power switch to control the EBC. The ground power available light, which is a blue light, comes on when external power is connected to the airplane and the power quality is good. The light stays on until you remove the external power source at the external power bank. We hope this series has been both informative and inspiring. If you joined this series, don't forget to like, subscribe, and hit the notification bell so you never miss an update. Got questions or topics you'd like us to cover next? Drop them in the comment below. Thank you.